Let's review some transformations here. Remember, transformations are ways that we can move a figure around a coordinate plane. So let's take a look here. Our first one, we have a triangle. We got some points given, so we can graph those. So that should be fairly easy. There they are there. Now we're going to translate it using this vector. So a vector tells us the direction that we're going. And remember that this gives us a horizontal and a vertical direction. Okay, so the -1, that first thing is horizontal. And horizontal, see if I can spell. There we go. And the second one is vertical. So this 4 here is vertical. So they look like coordinates, but they're not quite. But they, in a way, they tell us the similar things. But so the first one's horizontal, how far we're moving left and right. Second one, horizontal. So if you have a point that's going -1, 4, it's going to go left 1 and down 4. It's going to go in that kind of direction, left 1 and down 4. Okay. So the first one is left because it's negative. The second one is down because it's negative. All right. So we'll go ahead and we'll make that transformation here. Let's connect to this, make this triangle. So here's our triangle. And now that we know that's left 1 and down 4, just take each point, move left 1 and down 4. So take this C, count left 1, down 4. We're going to end up right there. And that'll be C prime. A is going to move left 1, down 4. It's going to end up right here. And that's going to be A prime. And B, left 1, down 4, is going to end up down here, B prime. And there's our triangle. Remember, it's going to be congruent. So we moved this by the vector -1, -4, so it moved in this direction. The magnitude is the length of the vector, so if we take this little right triangle that is made by the vector, then we're going 1, 4, -1, -4, that is. So the magnitude is really just the length of that arrow, C. So you can use the Pythagorean theorem and say -1 squared plus -4 squared equals C squared. Now we had a definition that just said, yeah, that's the Pythagorean theorem there, but the definition we saw in class looked like this. It said, go ahead and take the square root. That's because we're solving there, all right, for the magnitude of the vector. And so the magnitude there is going to give us, well, this is the square root of 1 plus, this comes out to be 16. Okay, so that's the square root of 17. So that's the magnitude there. Okay, and so come over to this next one here. There's our triangle. Graph it if you haven't done so already. And then we've got to move this. We're going to go, which direction is this? Well, this is -2 and +1. So in the form of a vector, we'd write this as -2, +1. This is our left and right movement. This is our up and down. First coordinate says go left 2, and then we're going to go up 1. So C prime is going to end up there. A prime left 2 and up 1 is going to end up right there. That's going to be A prime. And then B prime, left 2, up 1. There it is right there. And let's connect it with some lines. And there's our triangle after everything's moved left 2 and up 1. So we moved with this vector that went left 2. So let's go draw a picture of it. We went left 2, and then we went up 1. Let's get that arrow out of there so we don't confuse you. So it was -2, 1, so we went left 2, and then we went up 1, and then that was our vector, going left 2 and up 1. So the magnitude is, again, the Pythagorean theorem. You can think of it there. We could take -2, we're going to square it. Take 1, we're going to square it. And we're going to square root because we're finding the length of that. Okay? And so the magnitude, we could call that M, we could call that L, let's call it M, that's fine. Okay, the magnitude is going to be the square root of, remember this is positive 4 and positive 1, and so that's going to be 4 plus 1 is 5, square root of 5. Okay, so that's how long the translation vector is. Okay, that's how far it moved. It moved, oops, which way did it go? This way. Okay, so it moved square root of 5 units that way. All right, well, let's go ahead and do some reflections. There's our translations. We can describe translations in words, in vectors, and in these rules like we had in number 2. Reflections, we're going to reflect across the line, all right? So we're going to reflect this across the x-axis. And so whenever we reflect, we're going to go take a point, count horizontally, actually perpendicularly to the axis, in this case the x-axis. So we're going to count perpendicularly, and then we'll travel across that same distance. C is 1 unit away, and so C prime is going to be 1 unit over the x-axis. Here's our axis of symmetry right here. All right. A is going to be, it's 1 above, so A prime is going to be 1 below. B is 5 above, so we're going to count down 5 and go 5 below. And so that'll be at negative 5. And there's B prime. Okay. All right. Now we're going to reflect across line y equals 1. Well, y equals 1 is this horizontal line right here. These are all the points that have the y value of 1. That's y equals 1. And so when a point is on the line of reflection, it's going to stay. This line's going to stay. This line is 1, 2, 3, 4 units away. So we're going to go 1, 2, 3, 4 units below. And it's going to end up right down here. And that'll be B prime. So there's our new triangle. Actually connects to the old triangle. All right, that's a reflection across y equals 1. When we reflect across y equals negative x, we got to remember what the line y equals negative x looks like. This is a line that goes through 0, 0, 1, negative 1, 2, negative 2, 3, negative 2, 4, negative 4, so on and so forth. 45-degree angle going down to the right because it's a negative slope. And when we reflect here, we can do this 2 ways. Again, like we just did before, we're going to travel perpendicular and then across. So we know C prime is going to be somewhere down there. Okay? Now, we investigated some shortcuts, some patterns, and we saw that the coordinates will just be flipped, and in this case, they're going to flip and become negative. So that AB, they're going to flip. So this is at 5, 1. And I'm going to come down here. When I come down here, my coordinates are going to have 5s and 1s, and that's it. But it's going to be, you can tell that's going to, hopefully you can tell, it's going to be on this side of the line. And so we get negative 1, negative 5, because they flip, and they both become opposites. So here they were positives. Positive 5, positive 1. So now they're going to flip negative 1, negative 5. And there is C prime. And then A prime, well, A was at negative 2, 1. So it's going to be right over here. And that's going to be at 1, negative 1, 2. Okay, so these guys flipped and they become opposite to become negative 1, 2. And then last but not least, this B point here, which looks like it's at 2, 5, is going to, well, they're going to flip. So it's going to have 5 comma 2, but it's going to be negative 5, negative 2. Oops, that's negative 4, negative 2. So we're going to end up right here. And there's our reflection. Reflecting, rotating now, 180 degrees. Okay, so when we rotate this, it works good to rotate the picture itself. So I'm going to try something here. All right, we'll see if I can get this to work right. Okay, so we're going to take this and I'm going to see if I can spin it. Can I spin it? So if we rotate this around, now you can rotate your whole paper, but it's hard to do that with video. So 180 degrees is a rotation like this. Now, ignore those coordinates for a moment. And what I'm going to do is I'm going to write down what it looks like. Well, this guy is 2 to the right and down 1. And so that's at 2, -1. This guy is 2 to the left and down 5. That's -2, -5 for B prime. And this A prime. This C is 5 to the left and down 1. That's -5, -1. And so what we're doing here, what I'm saying is this is what our new picture is going to look like. Whoa, I just erased it. Okay, so that's what our new picture is going to look like. Okay, so I'm just going to erase that. Okay, it doesn't exist. It's gone. Now we're going to put that back in place. Okay, now that I've made a big mess out of this. Okay, so our goal is to draw what we just saw a moment ago, and I just erased with my magic eraser here. Okay, so we have A prime is at 2, -1. There's A prime. B prime is at -2, -5. There it is. C prime was at -5, -1. So there's those points that we saw a few minutes ago before I erased them. And now we can draw our triangle. Okay. So the idea is there is a rule, and you can tell what the rule is, hopefully, or you may have remembered the rule. All that happened was the coordinates flipped. So this coordinate, this A, was -2, 1. Okay, and now, actually, I'm sorry, they didn't flip, they changed sign. Okay, but there's still going to be 2's, and A is going to be 2's and 1's. It's not going to change to like 5's and 3's or other numbers. Okay, so we do have a rule that said AB, when you rotate around 180, it's become -A, -B. You can remember that, but it's a whole lot easier to spin the paper, read them, and spin it back and graph. All right, either way it works fine. So, but don't get mixed up by remembering the wrong rule. You may want to verify by seeing, does it really spin it around? So if you use a rule, check to see that you use the right rule. All right, well, let's go try the next page. Okay, now page 2, we're doing with the help of Bentley. So here I'm going to give you a quick picture of Bentley. So there's Bentley, our new puppy, that I'm puppy sitting right now. So if you hear him yip, then that's it. Maybe he'll get some answers. Maybe he'll help with some transformations. Okay, so now we're going to do a little what do we call these? Composite transformations. All right, so we've got some composite transformations where we're going to do 2 parts, 2 transformations. All right, so we're going to start by translating -5, 1. That means we're going to go left 5 and up 1. So we're going to do the first one, and then we'll plot that. There we go. Oops, it looks like I made a mistake with B. Remember, this is a rigid transformation, so it should be exactly the same size, all right? So now the coordinates, which we could have got beforehand, because we're moving to the left 5, we're going to subtract 5, and we're going to add 1 to all the coordinates. So like A was at -2, 1, so if we subtract 5 from that, we end up with -7, 2. B was at 2, 5, so if we subtract 5 from that, we get -3 from the x-coordinate. And if we add 1 to the y, we get 6. That's where we landed after fixing it. And C was at 5, 1. If we subtract 5, we get 0, and add 1, we get 2. And that's where we landed just by counting as well. All right, so now we're not done, though. That's just the first transformation. Our second transformation, we're going to take from the red one, and we're going to find the new one. And we're going to do that by reflecting across the x-axis. And we want to reflect the second one, the red one, across the x-axis. So we're going to take the A here, and it's down 2 to the x-axis, and it's going to go 2 more. And so we're going to end up with A double prime down here on the opposite side of the x-axis. And then we're going to have B. B was up at 6. We go down to the x-axis and all the way down. And so down at -6, we end up with B prime. We also had some rules, B double prime actually. We had some rules for these that you can use, but it's just as easy probably to remember how it's performed to perform that operation. So, but the rule, which you can see there, what happens is that x-coordinate stayed the same and the y-coordinate became opposite because we flipped over the x-axis. That was what happens when you flip over the x-axis. So while the rules are good to memorize there, it's more important to be able to figure out the rules after doing a little transformation, something like that. So, all right. So Bentley's keeping an eye on us here as he's chewing on my pants. Puppies like to chew. Well, let's chew on this here. So let's do a rotation counterclockwise about the origin, okay? So again, we can rotate it, all right? Just like, here we go, we can rotate Bentley. Okay, so you can rotate it and find it, or we can find out what happens when we rotate 90 degrees. They're going to switch places, and it's going to end up being like this. So we have A, B. They're going to switch places. It's going to be B, comma, A. And this point's going to end up going counterclockwise. It's going to go over here. Notice this is negative, positive. So the first thing is going to be opposite. So negative B and A, they switch places, and the first thing is going to be opposite. And you can kind of figure that out just by doing kind of what I did there with that blue line. So if we take all the coordinates here, like A is at -2, 1, and I'm going to switch them, and -2, 1 is going to become, well, I'm going to take the 1 and the 2 and put it first, and that negative, it was a -2. I'm going to flip them, and I'm going to change the sign of the first one. So A prime is going to go at -1, -2. There's A prime. So after switching them and changing the sign of the first coordinate to make it opposite, this is what we end up with. And so B is at -5, 2. B prime, that is. C prime is at -1, 5. And there it is. And when we connect them, we should get a congruent triangle. Now we're going to take that shape and we're going to rotate it. No, we're going to reflect it across the line y equals x. Now when we reflect across the line y equals x, the coordinates are just going to change. So here we'll graph the line first. So there's the line y equals x, and when we flip it, what's going to happen is this point here is going to come right across. It's going to travel perpendicular across to the other side. And when that happens, it's going to be right over here. And it's useful to remember what happens to the coordinates here. This is a good rule to remember. This is the rule where AB just flips, because y equals x, and so it goes to B comma A. All right. And so this guy here, which was -1, -2, is now going to be -2, -1. And we'll flip them all. And flipping them all, we can graph them. And once we plot our points, we can draw our triangle, which should be congruent. And there we have our final triangle, the red one there. So, composite transformations. Remember, we do one right after the other there. Couple more little problems, types of problems that is. So next one, we're going to identify congruent shapes because we've been talking about transformations that are rigid transformations. They go from one congruent shape to the other. And so here, we've got a bunch of shapes, and you can do these actually in any order. We want to pair them. You see we got 6 shapes, and so we've got 3 pairs. 3 pairs. So we've got... All right, so we're going to translate these guys or figure out what transformation that is. And we do have a translation here. See this little trapezoid? It's going up and to the right. Or you could say it's going left and down. Doesn't really matter. You can say either way. And so when it does that, we have this one on the bottom left that's TSUV. That's the name of this guy right here. TSUV, we name it by the points around it. And it's becoming this guy right here. So we'll name that FGHE. Okay. We'll talk more later about the order of the letters, but we'll just name them with the letters that are around them. Okay, they should kind of be in the same order, but we'll talk more about that later. Not too worried about that right now. So we notice what's happening. How's that being translated? And so, well, first we're going to say that it is a translation. You can define that translation in several ways. In words, you could say right and up, or you could do it in a vector, or you could do it in a rule. Okay, so let's go with a vector. Let's try that. Notice the S is going right. There's 3, 4, 5, 6, 7. Going right 7 and up 1, 2, 3, 4, 5. So we're going right 7 and up 5. I'm going to write that as a vector. 7, 5. Again, you could do it in words. You could say right 7 up 5, or you could do it as a rule. That's fine. All right. So next one here. Let's connect these. How about these two? Well, that's a reflection key. You see this one's flipping over there, or this one's flipping over that way, whichever way you want to see it. And so we have LMN, and this is a triangle, so we actually can use a triangle symbol. We'll talk more about that in the future. LMN. Well, L is going to I, M is going to K, and so we got I, K, and N is going to J. And so IKJ. Let's make that a little more legible. So that's a reflection, as we said. And what is it reflecting across? Well, it's this line right there. And that is a line, whoa. What is it? Yeah? Okay. So I think he said X equals 1. So across X equals 1. That's what he said. Good thing I have my puppy to help keep me straight here. Okay, one more. We have, let's see, we've got this guy, this triangle is going over here. And so it's going to do that little spin move. It's rotating. See how that C spins around? And we've got things spinning around. So that's a rotation. It's going around about the origin, spinning around. C is going to go to P, D is going to go to R, B is going to go to Q. So we can name them like this. I'll go B, C, D. It doesn't really matter what order you name that one in. Really, this next one we should name in the order. So B is going to Q, so Q should go first. And C is going to P, and D is going to R. When you spin it, that's where they're going to land. C is going to land there. D is going to land on the R. And that's a rotation. That's 180 degrees about the origin. Now with 180 degrees, we don't have to say if it's clockwise or counterclockwise because you can go to the left or to the right and you'll land in the same spot if you're going 180 degrees. But if you're going something less, like 90 or 270, but that's just more, you got to say which direction. So, okay, the last one here is a little practice. Now, you might want to do some flashcards on these rules. That's not a bad idea. But you can also kind of figure them out again. Hopefully, a lot of what we did in class was we spent time figuring these rules out. And so you can just kind of recreate that for yourself by thinking of a point here, A, B, and think about what happens to that point when we do these things to it. what happens when we reflect across the y-axis? Well, AB, or XY, notice they said X and Y here, okay? It's written XY, so let's call that XY, okay? So if I take this point, and right now it's X comma Y, and I flip that across the y-axis and reflect it, it's going to here, well, the y-coordinate is going to stay the same, but that x-coordinate is going to change, right? It's going to be over here, and so it's going to be the same y-coordinate, but the x is going to be opposite. All right? Now, if we rotate this 270 degrees, okay, so 270 degrees is a 3/4 turns. The first turn is going to take it up to there. Second turn is going to take it down to there. That's 2/4. The next turn is going to take it down to here. Okay, so with the 90 degrees and the 270-degree turns, what happens to that is they switch. So it's going to be y comma x. And think about this. I'm down in this bottom quadrant here. That's a positive first coordinate and a negative second coordinate. So that's going to be a negative. So it's going to be y negative x. Now, again, if you've got your flashcards and memorized it, great. But that's kind of how you can remember it, okay? Now, translations, these ones are a little easier to remember. If we're going right, that's going to be adding 3 to the x. And then down, that's going to be taking the y down to 7, okay? And then last one here, challenge. What if we do two things? What if we take this point, we reflect it across the x-axis? Okay, let's do that. When we take it down here, well, the first coordinate stays the same, and the second coordinate's going to change. And then we're going to rotate it 90 degrees. Okay, and that's going to be counterclockwise. So when we rotate it 90 degrees, it's going to spin up here. This is a challenge problem, remember. Okay, and what happens? Well, they change places. So that negative y is going to go first and the x is going to go second. But then what happens is, in this case, we're going to change that first coordinate to its opposite, which makes it positive yx. So there it is. After the combo, we got that. Okay, so we made it. We made it here while doing a video and puppy sitting at the same time, and trying not to get my stylus all chewed up. So, all right. Well, we're rooting for you. Bentley's rooting for you too. So study hard, work hard, help each other out, ask questions, and you're going to do great. So keep it up.